Welcome to the video on factoring, and this time our leading coefficient a will be greater than 1. Our goal is to factor these functions and sometimes use the discriminant to determine whether a quadratic polynomial is factorable or not. So we're going to begin with something that we can factor without using the discriminant or using our new techniques. The first thing you should always try to do when you are factoring is take out the greatest common factor. So take out GCF. Let's do that in the first example here. What is the greatest common factor between all these terms? Well, 2 can come out of all of those terms. And then I'm going to divide each of these by 2 to get the remaining trinomial inside. I get x squared plus 7x plus 6. And now, just like we did the other day, we're going to look for factors of 6. And since the last sign is positive, my factors have to add to be 7. Of course, 6 times 1 gets you 6, and 6 plus 1 is 7. So that will work. So then in my parentheses, I know I'm going to have x times x, and I'm going to have plus 6 plus 1. And don't forget the 2 on the outside that you pulled out at the very beginning. You need to have that there. The only problem is, in this one, since I don't have a greatest common factor, I have to use a different strategy than normal in order to find what the 2 factors will be after I factor this quadratic trinomial. And here's my technique. What you want to do, take the first number times the last number. 10 times 3. That's 30. And again, look at the last sign. Because it's positive, I know the factors of 30 have to add to be 17. What factors of 30 will add to be 17? Well, 15 times 2 is 30, and 15 plus 2 is 17. Good. Now, in the front spot, I need to somehow get 10, right? So I can't have just x times x for my first product because that would just give me x squared. I'm going to need coefficients times that. Now, using these 2 factors that I know have to work, are there any factors of 15 that will help multiply to be 10? Think about that. What needs to multiply to get 10? You could try 5 and 2, 1 and 10, but 1 and 10 aren't factors. Well, 1 is factors of both these, but 10 is not a factor of either of these. And so I wouldn't be able to use 1 and 10, but I can use 5 and 2. So if I put a 5x here, then 5 has to go into one of these 2 items. Well, of course, 5 goes into 15, and it's 5 times 3. Now here I have the 2x. Now the 2 didn't go into 15, but the 2 can certainly go into positive 2. Alright, so now I have 5x times 2x. That will give me the 10x squared that I need. Now for the remaining 2 spots, I need to think about how I need to get 5 times 3 to get to 15. Now if I put the 3 in this spot right here, if I put 3 there, the 5 will never multiply by the 3 because by the FOIL algorithm, when I multiply 2 binomials out, I do first times first, outer times outer, inner times inner, and last times last. So if I put the 3 here, the 5 will never multiply by the 3. So that means that this 3 has to go over here. And that means that this factor, 2 times 1 gets me 2, has to go here. 5 plus 1, 2x plus 3. Let's double check the outer and the inner products to make sure that this will add to be 17. We have 2x in the middle, 15x on the outside. If I add those together, I get 17x in the middle. Check the last. 1 times 3 gets me 3. All right, that's the correct factorization. 5x plus 1, 2x plus 3. Let's go through some more examples because I know that was a little confusing to some people. Let's look at this example. Now, instead of just looking at the factors of 3, I have to multiply the leading coefficient. If it's bigger than 1, if this a value, remember I talked about ax squared plus bx plus c. If we're in that format, if the a is bigger than 1, you need to multiply a by the c value. This time I get 6, and technically negative 6. But since the last sign is negative, I know the factors of 6 need to differ to be negative 5. Well, 6 times 1, that'll give me 6, and then since they need to differ, 6 minus 1 is positive 5. So I don't want that. I want 1 minus 6. Good. So those are the factors that are going to work. I'm going to set up my parentheses here. Now I can't put just x and x in the first spot anymore because that will give me x squared and I need 2x squared. So I know there has to be a 2x here at some point because that's the only factor of 2. 2 times 1. Does 2 go into either of these factors I've chosen? It does. It goes into the negative 6. Now 2 times what gets me negative 6? Negative 3. Now the negative 3 has to multiply by the 2. And if I put the negative 3 here, it won't ever multiply by that 2. So I have to put the negative 3 on this side. And the only factors of 1 are 1, right? And so it needs to be a positive 1 over here. Let's check to make sure that my factorization is correct. 1 times x is x. 2 times negative 3 is negative 6x. When I add those together, I get negative 5x, which is what's in the middle. And finally, 1 times negative 3 gets me negative 3, so I factored that correctly. Let's go on this side. Again, since the a value, I look for a common factor. There's no common factor to take out. 3 times 8 is 24, and since the sign is negative, I know that my factors of 24 need to subtract to be 10. What multiplies to be 24? 12 times 2. Great. Now, does 12 minus 2 equal positive 10? It does. So if I start to draw my parentheses for this one, I know that this needs to multiply to be 3w squared. So I'm going to have 3w and a w, and that'll give me my 3w squared. Now, on this side, 3 can't go into 2. So this 3 from this spot needs to go into 12. And 3 times what gets 12? 4. All right, and now that 4 can't go in the first spot next to the 3 here because I need to multiply the 3 by the 4 to get the 12. So the 4 has to go on the other side. And that means 2 times 1, I can either put, this is already the one that was used right here. So 2 times 1 would be there. So there you have it. Check the inner product. 2w, 12w. That's, oops, should be a negative 2. I apologize. I forgot that. So let me fix that here. This should be a negative 2. So negative 2 plus 12 gives me positive 10w. That's right. So my factorization, I'm just going to write it neater down here. 3w minus 2, w plus 4 is my answer for that factorization. Look for a common factor first. Can I pull anything out? 6, 11, 3, x squared x. Nope, I can't. Multiply the first times the last number. I have 18. Since the last time is positive, my factor used to add to be negative 11. So that means if they add to be negative 11, both of them have to be negative. So what multiplies to be 18? Well, 9 times 2. In this case, it's going to be 9 times negative 2. Great. And so since now I have a 6 in front, I need to get something that multiplies to be 6 out of these two factors. Well, of course, the negative 9 has to be a 3x. And then this has to be a 2 for that one, 2x, 3x times 2x. So 2 times negative 1, 3 times negative 3. I got those second numbers, the negative 3 and the negative 1, based on what I had to multiply this factor by to get the negative 2. And I got this negative 3 because I knew that I had a negative 9 up here. 3 times negative 3 gets me negative 9. Now this negative 3 has to multiply by this positive 3. So that negative 3 has to go on the other side. And that negative 1 has to go over here, so it multiplies by the 2 when I do the inner product. Let's double check my factorization. Negative 2x, negative 9x. Okay, so that means negative 11x. Is that what I wanted? Sure was. When I add those together, I get negative 11x. If I do the last product, negative 3 times positive 3, negative 3 times negative 3 gets me positive 3. That's my correct factorization. In this one, look for the greatest common factor. There is one this time. I can pull up the negative 2, and that makes my factoring job just that much easier. I divide all the terms by negative 2, and I get y squared plus 5y plus 6. And so now this becomes much easier because now I just need to look at the 6 and get factors that add to be 5. Factors of 6 to add to be 5, 3 and 2. So I have negative 2. That's going to be y plus 3, y plus 2. Boy, that seems a lot easier based on the stuff that we've done just before this, right? Okay, how about this one? So we have any common factors here between 7, 31, and 12? Nope, we don't. Unfortunately, this one's not going to be as easy. So 7 times 12, 7 times 12. So 7 times 10 is 70. 7 times 2 is 14. So it'd be 84. I need factors of 84 that will add to be negative 31. And of course, that means both of the factors of 84 have to be negative. So what multiplies to be negative 4, or multiplies to be 84? That's a little bit tougher to think about. Well, just try something. Let's do 2. 2 times what? Well, that would be 42. And if they both have to be negative, that have to be summed to negative 44, so that doesn't work. Here's a trick. If the digits add to be a multiple of 3, 8 plus 4 is 12, that means 3 can divide it. So what about negative 3? How many times does negative 3 go into 84? Don't know. Use a calculator to divide. I'm going to just divide here. 3 goes into 8 twice. Okay, so that is 6. Leaves 2 left over. Bring down the 4. 3 goes into 24. 8 times 28. Negative 3, negative 28. Will that add to be negative 31? It sure will. Great. Now the first box has to have a 7n. That's how I get 7n squared. 7n times n is 7n squared. Which one will 7 come out of? It'll come out of the 28. 7 times what? Negative 4. So then the negative 4 can't go in the box next to the 7. Now in the 3, I already used the positive 1 right here, so I need to multiply by negative 3. And there you have it, 7n minus 3, n minus 4. Let's check the inner and the outer products. Negative 3n, okay, negative 28n. When I add those together, let's get negative 31n's. That's great. Check the last product. Negative 3 times negative 4, positive 12. I know that this works. Fantastic. Now this one, no common factors to speak of. But I could rewrite this a little bit easier so we could get the picture. There are no x's in there, so I'm going to write 0x just to help me out. Now I multiply 16 times 1 to get 16. I need factors of 16 that add to be 0. Well, 4 and negative 4. Great. That will work. So now I need to get factors that of these numbers that multiply to be 16. I can't do 16x times 1x because 16 doesn't go into any of those. So I can't do 16 times 1, but I can do 4x times another 4x. That means out of each of these two factors, I have to take a 4. That's 4 times 1, so the positive 1 has to go on this side. 4 times negative 1, so the negative 1 has to go on that side. Let's check to make sure it works. 4 times 4 is 16x squared. Negative 4x. Positive 4x, when I add those together, nothing in the middle. That's great, because then I won't have anything in the middle. Negative 1 times 1 is negative 1, so I've had my factorization. 4x minus 1, 4x plus 1. Don't worry about this assignment unless you want extra practice. If you have your math textbook at home, your Algebra 1 book, you can practice by going to page 614 and doing these numbers 19 through 31 odd. Now the answers of the odd ones in the back of the book. If you're studying for a test or a quiz, this would be great practice for you to prepare. Do the work, test it out, and then check in the back of the book to see whether your answer is right. Have a good day.